Hello. We're on our first installment of quotient properties involving exponential functions. We did powers, we did products, we included both at the same time. Now we're going to have quotients included in that. And what a quotient is just a division sign. And students get a little intimidated when they see it at first, but as long as you keep things into perspective, it's not so bad. So I want to show you how it works theoretically, and then just show you the property afterwards. So for my first one, I've got 3 to the 5th, which is 3 times 3 times 3 times 3 times 3. That's 5 times. Over 3 to the 2nd, which is 3 times 3. Now what happens here is 3 divided by 3 is 1. It doesn't cancel, it actually becomes a 1. And this 3, well, you can pick any one of those 3's at the top. Divided by another 3 is another 1. So all I've got in the numerator is 3 times 3 times 3. Or I have 3 to the 3rd. But I'm not going to leave it as 3 to the 3rd. I'm going to make it 3 times 3 times 3, which is 27. Finito. That's it. X to the 5th is the same thing as x times x times x times x times x. Over x to the 2nd, which is x times x. Let's cancel that one, just to add some j's to it. It's x to the 3rd, and there's nothing else I can do. Now maybe you've noticed this and maybe you haven't, and this is the spot where I'm going to stop and tell you this. If you have the same base, if you're dividing the bases and they're the same, and let me say that again, there's a division sign and the bases are the same, then all you do is you subtract the exponents. 5 subtract 2 is 3. 5 subtract 2 is 3. So this is 3 to the 3rd, but you have to simplify that, which is 27, and x to the 3rd, and you can't do anything with that. Continuing along, I want to try that without writing it out now. So I've got the bases. Are they the same? The answer is yes. The bases just mean the number in front of the exponent. I've said that before, but I'll say that again too. And 5 subtract 2 is 3. So it's quantity of 3 to the 3rd power. Now that means it's negative 3 times negative 3 times negative 3, which is negative 27. And I would always prefer you to go the extra step, but it depends on what your teacher is asking you to do. This one confuses students, and they look at it and they get a little flustered. There's really no need to get flustered. It's 1 over x squared times x to the 5th. That's x to the 5th over 1. 1 times x to the 5th is x to the 5th. X squared times 1 is x squared. Same base, division, subtract the exponents, x to the 3rd. It wasn't coincidental that the problem was exactly the same, just so you could see that. Divisional exponents, quotient exponents take on another beast too, which will be introduced later, but it's best to practice this before we introduce that. What happens if the exponent, you know what, let's change that. Let's make that 3 to the 2nd. What happens if the exponent in the denominator is bigger than the numerator? Because all these worked out pleasantly. Or what happens if the exponent is the same and the bases are the same? Well, I'll show you what happens. X to the 2nd is x times x. X to the 5th is x times x times x times x times x. These divide out. Now they don't cancel, they become a 1. So what I have is I have a 1 here. Since there's nothing in my numerator, I have to put a 1 as a placeholder. And students say, well, why do I have to put a 1? It wasn't there. Actually it is, because x divided by x is 1. X divided by x is 1. There still is a 1 that exists there. And the answer is 1 over, and there's x to the 3rd. Now some people might say, I didn't get that. I did what you told me to do, and I got x to the negative 3rd. And the answer is they're the same. If your teacher wants you to simplify using negative exponents, this is the answer. But if your teacher wants you to put positive exponents in, then that's the actual answer. And that will be explained when we get to 0 exponents. And it will be explained when we get to negative exponents, actually, for that one. But they have to work entirely the same. But it's good exposure to see it now, because you're probably going to see an example like that and get a little confused. 3 to the 2nd over 3 to the 2nd is 3 times 3 over 3 times 3. 3 divided by 3, 3 divided by 3 becomes 1 over 1. That's the answer. It's 1. Now somebody's going to say, no, I did what you told me to and I got 3 to the 0. Well, here's the trick. anything to the 0 power, except the number 0. Except the number 0. That's actually undefined, and I'll tell you why. It's actually, it actually goes under a calculus concept under L'Hopital's rule. That's much later on. Well, it's not exactly like that, but you can make connections to it. Anyways, anything to the 0 is 1. And these two will be explained in their own particular lesson. Not yet, though, but I thought exposure would be good. But what I want you to ascertain from what we're doing right now is that if you're dividing bases that are the same, all you do is you subtract the exponents. That's the main objective of this particular video clip. Other than that, I will see you later. Have a great day. Goodbye.